5.3, properties of logarithmic. Okay, let's just leave it right there. It should say properties of logarithmic functions. We're going to talk about several things. Change of base is one of them. You know, back when I first started dealing with logarithms, there was no such thing as a log button on the calculator. So back in the day, for us to do logarithms, we had to use a table. We had a table of values to compute logarithms. And we would actually have to look at, so if I wanted to know what was the log of 16, I would say, okay, log 10, 6, 16, there it is, huh? Yeah, yeah. Like z-scores for stats, like times tables for third graders, right? Okay, I don't know. Log base 10 of 16, I don't know. And then later on, we got calculators that had a log button. But anytime you do a log, look at the log button on your calculator. What else do you see on that same button? 10. Because log, if I just said, what is the log of 16? We understand that I'm talking about base 10. That's just understood. It's called a common logarithm. So when you did logs with the paper, you would pull out your common log table. Well, what if I was asked what's log base 3 of 12? Well, here's the problem. I have a log table for common logs. I have a log table for base 10. I don't have a log table for base whatever I said a minute ago, 3 or whatever. I don't have one of those. So what we had to do is called change of base. I had to change that log base 3 of 12 into a log base 10 problem. Then I can use the table. Okay, we're about to show you. It's not hard. We're going to talk about a lot of properties of logarithms today to rewrite logs. We're going to expand and condense log expressions, and then of course word problems.
That was just like a story about your past because you were reminiscing, but I guess not.
Okay, so change of base. The way change of base works is very simple. If I have log base a of x, pay attention to the location of the a and the location of the x. The a is lower than the x is, right? That means a goes on the bottom and the x goes on top. So log base a of x is equal to log base, whatever you want to use, divided by log of the same base. So it doesn't matter what log you choose, but you must have the same base here. So log base a of x is equal to log base b of x divided by log base b of a. Okay? These next two statements, they're exactly the same thing. If I'm talking about common log, that means I'm talking about base 10. Remember, if you don't see a number on a log, we understand that it's base 10. So log base a of x is the exact same thing as log x divided by log a. And when I say log x divided by log a, what's my base? 10, because it's a common logarithm. I don't have to state it. Okay. What is natural log? What is the base for natural log? We talked about it yesterday. What is the base for natural log? E. So if I wanted to change log base a of x to natural log, it would simply be natural log of x divided by natural log of a. Done. Okay. Keep in mind, this is the same thing. I'm going to kind of talk about it as a b. Log base e of x divided by log base e of a. But we don't ever write log base e, but understand that log base e is natural log. Questions on that? No. I don't have an x divided by a anywhere up there. No, I don't have an x divided by a. I have a log x divided by log a. That's different. Okay. And I'm just moving on from this slide. So log base 4 of 25. How would I do a change of base on that? What goes on top? Log, common log. Okay, that's base 10. I'm doing a change of base right now.
questions.
I want to change a base. I want to change this to base 10.
Then put 10.
Don't have to.
Well, you don't have to use something. Oh,
Not if I'm changing base.
so then you just leave it and you just put
Log 25 divided by. Okay. Now, using your calculator, if you press the log button, that's log base 10, right? So using your I'm going to change this to approximately. Using your calculator, approximately, what is log 25?
1.39 or 1.4.
Okay. What is log 4? And if you take log 25 divided by log 4,
2.32.
about 2.33. Now, did you do 1.4 divided by 0.6, or did you actually do log 25 divided by log 4? Okay, what is log 25 divided by log 4? Okay, 3, 4, no. Okay. And so back in the day, for me, this problem, I'd say, okay, log 24, okay, that's 1.4. And I'd write down 1.4 divided by log 4, log 0, 4, okay, 0.6. And then I would take my calculator and go 1.4 divided by 0.6, and I would get my answer. Okay. Y'all are a little spoiled with technology. First of all, there's a log button, which I didn't have at first. But once I got the log button, I didn't have the ability to do what I'm about to show you. Press math. Go up to A.
Oh my gosh.
What's the base?
4.
What's the number?
25.
What's the answer?
2 point the exact same.
Okay. So y'all are
Okay, wait, what is it again?
math up. Math up. Yeah, but nobody's going to remember math A.
I am.
Okay, so I'm going to go ahead and clear this and move this. And that's what we did. Okay. You know from the preceding section that the logarithmic function with base A is the inverse function of the exponential function with base A. So it makes sense that the properties of exponents should have corresponding. For instance, if I took a to the u times a to the v, when the bases are the same, what do you do to the exponents? You add them. So a to the u times a to the v is equal to a to the u plus v. We can do the similar things with one of the log properties, and we're going to go into more detail with this in a minute. If I took log base, I don't care, of a product, the log of a product is equal to the sum of the logs. Okay? So log of u times v is equal to log of u plus log of v. I'm ignoring the base, but y'all just work with me here on that. Okay? I'm going to go to the next slide. You're going to see some properties. There's your properties. It's 2 columns, and those columns say the exact same thing, don't they? Y'all seeing it now? Understanding that log and natural log, we're talking about the same thing. They just have different bases, right? But the properties are exactly the same. When multiplying, the log of a product is equal to the sum of the logs. When dividing, the log of a quotient is equal to the difference of the logs. Notice whatever's on the top is a positive log. Whatever's on the bottom is a negative log. I'm about to show a more complex example of that in just a minute. Okay. And the last one says, if I'm taking the log of something that's raised to a power, you can take that power and pull it to the front. All right. So let me show you a more complicated version of number 2. I want to expand log, I'm going to leave it at base 10 because I'm lazy, of a times b times c divided by x times y times z. Okay. Will there be subtraction involved? Yes, because there's division, right? So division leads to subtraction. Will there be some addition involved? I'm multiplying these things together, so I'm adding, right? Now here's the catch. A, B, X, Y, and Z, though they're multiplied together, will all be negative because they're in the denominator. So to expand this, it would look like this. Log A plus log B plus log C. That's the top, fully expanded. Now expand the bottom. Minus log X minus log Y minus log Z. So I have fully expanded my basic logarithm that I started with. No need. Why would I need parentheses? All right. Moving on. Write each logarithm in terms of natural log of 2 and natural log of 3. I'm starting off with natural log of 6. My question for you is, can we express the number 6 using only 2s and 3s? 6 is the same thing as 2 to the third.
Wait.
Let's go simple. 2 times 3 is 6, right? Okay.
Even simpler, 2 plus 2 plus 2.
That's not going to help us.
That was
Okay. So I can rewrite 6 as 2 times 3, correct? Now, using the property that we just saw a minute ago, how could I write the natural log of 2 times 3? Did we do what the problem asked? The problem said to rewrite the logarithm in terms of natural log of 2, and that, meaning the only thing I can have are natural logs of 2s and natural logs of 3s. Okay. Part B. I need to rewrite this guy. But I can't use 1. That's not an option. So what do you want to do with the 2? Leave it alone. 27. Three to the third power, which is the same thing times 3 times 3. I'm actually going to work it both ways. Okay. So I can write this as 3 to the third, or we could say this is natural log of 2 divided by 3 times 3 times 3. And both of these are going to give us the exact same answer. Okay. All right. Natural log of 2 divided by 3 cubed. How could I rewrite that? Natural log of 2 to the third power. Okay, now we had a property that said something about those exponents. What can I do with that exponent of 3? Move it to the front. Here? 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 Okay, so natural log of 2 minus 3 natural log, which means I have 1 natural log of 2 minus 3 natural logs of 3. Did I write this in terms of natural logs of 3s? Okay. So what about the person that decided to write it as 2 over 3 times 3 times 3? That would be, let's expand that. Natural log of 2.
Plus.
No, it's on the bottom. The 3's on the bottom. So minus what?
Natural log of 3 times.
Minus natural log of 3 minus natural log of 3. Like I had XYZ on the bottom a while ago, right? I had minus natural log of X minus natural log of Y minus natural log of Z. Same concept. Well, what happens when I have minus natural log of 3 and minus natural log of 3 and minus natural log of 3? What is this? There's 3 of those, right? So that's the same thing as natural log of 2 minus 3 natural log of 3. Okay. Which way is better?
Doesn't matter.
Whichever one you understand the best. Okay. I will go ahead and delete my writing. I will move the box and you can see their solution. Any difference? Okay. They just sometimes like to skip steps. I don't think they did on this one. Tells you which property, yeah. The properties of logarithms are useful for rewriting logarithmic expressions in forms that simplify the operations of algebra. This is true because these properties convert complicated products, quotients, and exponential forms into simpler sums, differences, and products. Let's take a look at some of this. I want to now expand log base 4 of 5x cubed y. Let's expand that because that's what it tells us to do. We can leave the base alone. We're just going to be writing that base 4 over and over and over and over again. This doesn't say anything about changing base. It just says expand it. So we're going to leave it in base 4. Log base 4 of 5 plus log base 4 of x cubed because 5x cubed and y are just all multiplied together. There's one more thing I can do. Move to 3. Yeah, perfect. Yes. Plus 3 log base 4 of x plus log base 4 of y. And that is the final answer for part A. Well, once you do this for a while, you probably would not have written this line. Once you got to this part right here, you said, okay, log base 4 of x cubed, I need to pull the 3 out front. And you just do it. Yeah, y'all will get there sooner than you think. Part B. What am I taking the square root of? Can you separate that? You cannot. Square root is grouping simple. I have to figure out what 3x minus 5 is before I can do the square root. And since I don't know what x is, I can't figure out what 3x minus 5 is. Okay, so you want to, that's the square root. Okay. Okay, am I done? Okay, y'all gonna have to think about this. I'm gonna make a statement. Think about this. No, I'm not done because there is an exponent up there I need to move.
Oh, it's when do we have to imagine
The square root. The square root. What? How can you rewrite that? The square root.
Put 2 natural log. Maybe wait, is it?
The square root. How do you write square root as an exponent? No, that's squared. 1/2. 1/2. So what this really is natural log of 3x minus 5 to the 1/2.
The 1/2 is part.
Now we can clearly see the 1/2 needs to come out. 1/2 natural log of 3x minus 5. Are those parentheses needed? 100% needed. Absolutely. Otherwise, it would look like 1/2 3x minus 5. That's not what it says. Okay. Good job. Questions? Okay, I'm going to clear my writing. Move my box. There's part A. And here is part B. Moving on. I'm glad y'all are so nice to each other and loving.
You know, if you meet a one side of the answer.
Okay.
Cancer.
Okay, we have about 6 minutes left to go in class. I don't want to start this problem with only 6 minutes. So I'm sorry if you're not going to be here tomorrow. You can watch second period. You can watch second period in its entirety, has been done already, or you can watch part 2 of this class after I record it tomorrow. Okay. There's a lot of people that are missing this time of year.